Hello students, I am Dr.S.Shenbagavalli, Assistant Professor, Department of Physics, SFR College for Women, Sivagasi. Today I am going to see about classification of engineering materials. These are the objective of, so learn about the engineering materials, classify the type of metals, analyze the factors affecting the selection of metals, learn the engineering requirements of metals. The classification of materials in material science and engineering are the chemical component of the materials. Next one, the mode of the occurrence of the materials in nature, and third one is the refining the manufacturing process to which the materials is subjected, period it acquired the required properties, and fourth one is the atomic and crystalline structure of materials, and fifth one is industrial and technical use of the materials. The common engineering materials that within the scope of the material science and engineering, it may be classified into one of the following 7 groups: metals and alloys, ceramics, polymeric materials, composites and electronic materials, biomaterials and advanced materials. So first one is metals. So all the elements are broadly divided into metals and non-metals. So according to their properties, the metals are the element substance which readily give up electrons to form metallic bond and conduct electricity. So some of the important basic properties of the metals are, the metals are usually good electrical and thermal conductors, and ordinary temperature metals are usually solid. The most of the metals form alloys when 2 or more pure metals are melted together to form a new metal whose properties are quite different from those of the original metals. It is called the alloy. So the metallic material possess the specific properties like plasticity and strength. The few favorable characteristics of metallic materials are hardness, resistance to corrosions, good thermal and electrical conductivity, stiffness, and the properties of magnetism, etc. So the metals may be magnetic and non-magnetic in nature. So these properties of the metallic materials are due to the atoms of which these metallic materials are composed, and in these atoms are arranged in the base lattice. The metallic materials are composed in arrangement in the base lattice. So the metallic materials are typically classified according to their use in the engineering. So first one is pure metals. So generally it is very difficult to obtain the pure metals. Usually they are obtained by refining the ore. Mostly the pure metals are not of any use of the engineering. So however, by specialized and very expensive technique, so one can obtain pure metals, for example aluminum and copper. So next one, alloyed metals. The alloys can be formed by bending 2 or more metals, or at least one being metals. The properties of an alloy can be totally different from its substance. For example, stainless steel. Next one is porous metal. The iron is the principal consistence of these porous metals. The porous alloys contain a significant amount of non-porous metals. The porous alloys are extremely important for engineering purpose. Next one, this is the example of alloys and porous metals. Mild steels. The percentage of carbon in these materials is range from 0.15% to 0.25%. These are strong and have good weldability. This production cost of these materials is also low. Next, medium carbon steels. These contains the carbon between 0.3% to 0.6%. The strength of these materials is high, but their weldability is comparatively less. This is an example of mild steel and medium carbon steel. High carbon steels. These carbon steels varying from 0.65% to 1.5%. These materials gets caught and tough by heat treatment, and their weldability is poor. So the steel formed in which carbon contained in up to 1.5%, the silica up to 0.5%, and the manganese up to 1.5%, along with the other elements is called the plain carbon steels, cast iron. The carbon content in the substance vary between 2% to 0.4%. The cost of production of this substance is quite low, and these are used as porous casting alloys. These are the example of high carbon steels and cast irons. Non-porous metals. These substances are composed of metals or other than ions. However, these may contain ion in small proportions. Out of several non-porous metals, only 7 are available in significant quantity, reasonable at low cost, and used as common engineering metals. These are aluminium, tin, copper, nickel, zinc, and magnesium. Some of other non-porous metals, about 14 in number, are produced in relatively small quantities, but these are vital importance in modern industry. This includes chromium, cobalt, tungsten, vanadium, titanium, manganese, etc. So next one is sintered metals. These materials possess very different properties and structures as compared to the metals from which these substances have been cast. Powder metallurgy technique is used to produce sintered metals. These metals to be sintered are first obtained in powder form and then mixed in right calculated proportions. Finally, once get from sintered in the furnace, we must note that produced within the certain pressure. Finally, once get them sintered in furnace, we must warn that the mixture so produced is not the true alloys, but it possesses some of the properties of typical alloys. These are the example of non-porous metals. Another one, this is a sintered metals example. Glad metals. A sandwich of two materials is prepared in order to the advantage of the properties of both materials. This technique is termed as cladding. Use this technique. Stainless steel is mostly embedded with a thick layer of mild steel. By rolling the two metals together while they are red hot, this technique will not allow corrosion of one surface. Another example of this use of this technique is cladding of beryllium with thin sheet of pure aluminium. These surface layers, that is the outside layer of aluminium resist corrosions, whereas inner layer of beryllium impart high strength. This technique is relatively cheap to manufacturing. So this is example of glad metals. So another one topic is polymeric materials. Most polymeric materials consist of organic long molecular chain or networks. Structurally, most polymeric materials are non-crystalline, but some consist of mixtures of crystalline and non-crystalline regions. The strength of duality of polymeric materials vary greatly. Because of the nature of their internal structure, most polymeric materials are poor conductor of electricity. Some of these materials are good insulator and are used for electrical insulating applications. So one of the more recent application of the polymeric materials have been manufacture of digital video disc. So in general, the polymeric materials have low density and relatively low softening or decomposition temperatures. So this is a common use of polymeric materials. So next one is the organic, inorganic materials. So organic materials are carbon based and their derivatives. There are solid composed of long molecular chains. The organic components is very important because all the biological system are composed of carbon components. These are also some materials of biological origin which do not possess organic composition. For example, limestone. So first one is organic materials. These materials are carbon component in which carbon is chemically bonded with hydrogen, oxygen and other non-metallic substance. The substance of these components is complex. The common organic materials are plastic and synthetic rubbers which are termed as organic polymers. The other example of organic materials are wood. Many type of waxes and petroleum derivatives. The organic polymers are prepared by polymerization reactions in which simple molecules are chemically combined into long chain molecules or three-dimensional structures. The organic polymers are solid composed of long molecular chains. These materials have low specific gravity and good strength. The two important classes of organic polymers are thermoplastic and thermosetting plastic. The thermoplastic, on heating this material, becomes soft and hardened again upon cooling, for example nylon, polythene, etc. Thermosetting plastics, these materials cannot be re-softened after polymerization, for example urea, formaldehyde, phenyl formaldehyde, etc. Due to gas linking, these materials are hard, tough, non-swelling and brittle. These materials are ideal for modeling and casting into components. They have good corrosion resistance. So, the excellent resistance to corrosions, each of fabrication into desired shape and size, lightweight, strength, rigidity. So, have established these polymeric materials, and these materials are fast replacing many metallic components. So, the PVC, polyvinyl chloride and polycarbonate polymers are widely used for roofing and cladding of the buildings. So, the plastics are also used for reducing weight of mobile object, for example car, the aircraft and rockets. The polypropylenes and polyethylenes are used in the pipes and manufacturing of tanks. The thermoplastic films are widely used as lining to avoid seepage of water in canals and lagoons. To protect metal structure from corrosions, plastics are used as surface coatings. The plastics are also used as main ingredients of additives. The lower hardness of plastic materials is compared with other materials, make them subjective to attack by insect and rodents. Because of this presence of carbon, plastics combustibles, the maximum service temperature is of order of 100 degrees Celsius. These materials are used as thermal insulators because of lower thermal conductivity. The plastic materials have low modulus of rigidity which can be improved by addition of filters, for example glass fibers. The nature rubber, which are organic materials of biological origin, is an thermoplastic materials. It is prepared from a fluid provided by the rubber trees. The rubber materials are widely used for automobiles, insulations of metal components, toys and other rubber products. So, next one is inorganic materials. These materials includes metals, glass, sand, wood, minerals and ceramics, and have minerals regions. So, these materials are formed due to natural growth and development of living organism and are not biological materials. So, rocks are the unit which form the crust of the earth. These three major group of rocks are igneous rocks, sedimentary rocks, metamorphic rocks. First one is igneous rocks. So, these rocks are formed by the semi-liquid of liquid materials. It is called the plutonic. If their consolidations take place deep within the earth and volcanic, if lava or magma on the earth of the surface. So, next one is sedimentary rocks. When broken down, remains of existing rocks are under pressure, and then the rocks formed name as sedimentary rocks, for example sandstone rocks. Third one is metamorphic rocks. These rocks are basically sedimentary rocks which are changed into new rocks by intense heat and pressure, for example marbles and slates. The structure of these rocks is in between igneous rocks and sedimentary rocks. The rock materials are widely used for the construction of buildings, house, bridges, mountains, arches, etc. The slade which has great hardness is still used as roofing materials. The other type of materials, that is pozzolanics, are of particular interesting to engineering because they are naturally occurring or synthetic siliconous materials which hydrate to form cement. So volcanic ash, blast furnace, some slashes and fly ash are example of pozzolanic materials. When the cement containing 10 to 20% ground blast furnace, then it is called blazono Portland cement, which set more slowly than ordinary Portland cement and has greater resistance to sulfonate solutions and sea waters. So the rocks, stones, wood, copper, silvers, gold, etc. they are naturally occurring materials exist in nature in the form in which they are to be used. However, naturally occurring materials are not made in numbers. Nowadays, most of the materials are manufactured as per requirements. Obviously, the study of the engineering materials is also related with the manufacturing process by which the materials are produced to acquire the properties as per requirements. So, the copper, silver, gold, etc. Which occur in nature in their free state are mostly chemically inert and highly malleable and as well as extremely corrosion resistant. The alloys of these metals are harder than the basic metals. The carbonates, sulfates and sulfides are more reactive metals. Biological materials, leather, limestones, bone, wax, wood, etc. are biological materials. The wood is fiber the composition of hydrocarbon, cellulose, and cellulose is used for many purposes. Apart from these components is a small amount of gum, starch, resin, wax and organic acids are also present in wood. One can classify wood, softwood and hardwood, and the flesh wood contains high percentage of water and to dry out it, if proper season is not done, defect such as cracks, twist, etc. So leather is obtained from the skin of animals after cleaning and tanning operations. Nowadays used for making belt, boxes, shoes, purse, etc. Thanks for watching this video.